All right, welcome back everyone to week 2, day 5. Here is one of the most challenging but rewarding algorithms that we have to give you. And it works based off yesterday's lesson. So yesterday we had a 2D array, and we were tasked with finding if there is a number in that array, or how to flatten that array. Today we are still working with 2D arrays, but we're given a lot more code here. We're given HTML, CSS, and even a JavaScript file. So as you can see here, there is a huge 2D nested array. And let me just show you the final goal of what we're making here. We're making this thing, this app, that when you put all HTML, CSS, JavaScript together, it will calculate the surrounding squares from the area that I have clicked. So for example, this area here, if I click this center square, this one with the dot, if I click this one, it will read all the surrounding squares. So all these values of the squares surrounding it will be read, minus the dot that I clicked. Okay, if I click, for example, this one here, okay, this surrounding area will be read. This square, this one is red, all these that are surrounding, minus the center value. Okay, so think of a way, the first step is to think of a way that we can click a square and count up the surrounding values. So for example, this one on the top left, well, let's not go to the edge cases yet, but let's go ahead and highlight a center. Excuse me, my drawing tool is not working. Okay, so if I click this center one, this center 0 here, I should get a result of 9 plus 0 is 9, plus 0 is 9, plus 3 is 12, plus 2 is 15, plus 3 is 18, plus 0, plus 0. So the total would be 18. If I click this center 0, I should get an 18 as a result. And as you can see here, I'm not sure I'll be able to find this exact 0. Maybe 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if I go here, I say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. I don't know if I clicked the right one, but I got a 17. And it will give me the surrounding values wherever I click. So it's tallied up everything minus the center. So in the end result, with the code given, you should be able to make this work. So the main work has to be done in the JavaScript. So you have to find a way to, I'll just give you some hints here. There's a couple ways to do it. There's a way to do it through if statements or through for loops. Okay, imagine you click this center one. How can you then make it loop through through this row above for only 3 spaces, starting to the top left area of the center value? Okay, only 3 spaces, and then iterating through the row that I selected originally, and then going through this row and these 3 column spaces starting from the value to the left all the way to the right. Okay, so you'd have to make it loop only through this square. Okay, then when you go through the square, then you would have to then add up the values and then subtract the center value. Or you can use if statements to say, if there's a value here, if there's a value here, if there's a value there, then add it up. Okay, there's a way to do it through if statements. What you need to consider as well is the edge cases. So, for example, if I choose this one here, this one at the very edge, what is the 3x3 square that would be surrounding it? It would be a 3x3 square in this area here. But as you can see, this has there's no values above and there's no values to the left. So those would be undefined. This area would be undefined, right? Because it's outside of the 2D array. So then we would have to also consider the fact that when we are looping this 3x3 square, that if we encounter any values that are undefined, that we would not add those to the sum that we would be displaying, like when we click the center. Okay, so let me not switch yet. So for example, if I choose this 0 here, there would be a 3x3 square. It would either check through if statements or for loops. This area above, which has no definition, it's undefined what those values are. It would still iterate through this row, calculate that value on the left, 8, and then it would check here and it would notice there's undefined, so it wouldn't do anything with this value. And then it would add these 2 8s on the bottom as well, but then there's this space on the bottom right that it would not add. So you have to consider also the fact that anywhere you may click, you may get an undefined as well. Okay, whether anywhere on the edge, on the bottom, on the corners, on the top. All right, so that's the goal. And this is a challenging one. All right, this is one of the first real challenges as far as algos. I mean, everything's been challenging so far, but as far as a difficult level algo, this is a good one to do. And so look at also this code here. We have a for loop within a for loop. And we have I at 0, j at 0. And we are going to use this nested for loop with our own for loop, right? Because what does this for loop do? It says this creates rows of buttons for this game. So this is what creates all the buttons that we see available. So out of this array of arrays that every time we get to the inner for loop, we plus equals the buttons here, use the values that we see here to create the for loop. Okay, I don't want to give too many hints until I see you guys struggle to the point where the hints actually make sense. So I will be giving you guys this code shortly and then going into the rooms. When you guys have the critical moment where you need the hint that it will make sense, then I'll hopefully be there to give it. I'll be checking on all the groups. So again, whenever you click on a number on a button, I want to see the surrounding 3x3 block of values appear in that center click. Okay, there's some bonus challenges to draw the number on. Okay, don't worry about these bonus challenges. Read them on your own time. I don't want to overwhelm, because this challenge is by itself what I've given enough to keep us busy probably for the whole hour. So if you do want to do these challenges, they're there. and I would be really impressed if you got to them and were able to complete them. Okay, with that having been said, does anyone have any questions? Everyone understand the challenge then? Okay, great. Let's get started. Okay, welcome back, everyone. Let's go ahead and share our results. Any group that has the answer was able to make it work.
We got ours to work.
Awesome. All right, Mike, let's share your screen and let's go through this slowly. Let's try and describe it as thorough as possible.
Okay. We did get the 3 challenges done, and one of them involves changing the arrays. So, all right, let's see. Okay, so challenge number 1: draw numbers of learning it. All right.
So you redefine the array to all zeros?
Yeah, just I figured that was the easiest way because I wanted to just put 10 random ones in there instead of just having it reassign everything to 0 and then randomly assign 10 random ones.
Okay.
I just figured that was the easiest way to do it.
It's different. Let's do it without the chat. Can we do this without the augmented array? Can we just go with the original array?
You can. It'll just be a little bit longer. I guess one way to do it is just go through it, reset everything to 0, then do the randomizer.
Okay.
Actually,
this may be too advanced to share even if we got this working. So I don't want to say like you didn't do it correctly, but actually, I don't think you don't want to touch the original array.
Okay.
That's definitely not something.
Now that I'm thinking about it, what you could do is just ignore that, and then just right below this line, just reassign whatever that index is to 0.
Okay.
So
this may work.
Okay, I didn't think about that.
Don't worry about it then. Does any other group have this solution that we could use? Mike, not saying you did a good job.
Well, you're telling me I did a terrible job.
I just got rid of the second array.
No, so. Mike, I just didn't want to do too many bonus features at once for those that are just learning the base.
All right.
The base fundamental of how to get this done, how to make that nested for loop to iterate through that 3x3 block.
All right. I mean, I can still go through that.
Okay, then let's do that. Let's do that, Mike. Let's keep it with your screen.
More or less the same.
Okay.
Okay.
Fantastic.
So here, what I do is take in I and j. It'll tell us whatever the current indexes are, and I want to set them to be for the one to up and to the left of the one we click. Want to be -1, and the one to the bottom and the right want to be +1. Actually, I should probably comment this out because that's getting reassigned later. The only thing is that if it's greater than the index of the array, we don't want to exceed that. So I'm just doing a basic if-else statement here. If it's equal to 9, just leave it. If it's not equal to 9, add 1 onto it. So it gets up to a maximum of 9. So it does not go outside. And the reason that is from this loop down here for the conditions. So let's see because we have to set it to I start, which let's say it's 0. If it's less than I end, which would be 2. From that point, we go in and we have this if statement. We need to make sure that x is greater than 0, meaning it's not -1. So it's at least the very beginning of a valid array index, and that the end is less than the length. The length is 10, and the I end because of this will be at most 9. So if it was ever 10, this if statement would fail and would never enter in. And then we have the second for loop here with we have j starting, which let's say that would be 1, and that'll be less than j end, which should be equal to be 3. And then we go inside again, make sure it's not outside on the top. and then make sure j end is less than the length. And then from there, we'll just take whatever that index is. So this does not include anything from the left, from the top, from the right, or from the bottom. And it adds everything up into the sum, including the one that you clicked on, which we will subtract right down here. And I and j are unchanged. Those were passed in. That's the one that we clicked. So we just subtract it right here. I made sure to get different variables here because those are going to be modified.
Okay.
And then we just take the element and change the inner HTML to what the sum is.
Okay. Okay. Nicely done. The only thing, I don't think there's anything to comment on, actually. It looks like it's done really well. Oh, well, I guess I could comment on what, so you defined is start as I minus 1 instead of within the for loop. So that's
I did think about that, yeah.
You could have defined it in the for loop. You could have said x equals
yeah, that's true.
1.
Yeah, that's true.
But you know, it's still readable. It's still nice.
I guess because I just started this up here and I didn't think about it until down here. But yeah, that's one. That's one way to trim it down.
Okay, let me give my solution here, and then we'll end this out because we're almost 30 minutes over the lecture time. Okay, so. And I'll share this code with you guys so you guys can really stare at it and dissect it. Here's the exact same thing that we just saw on Mike's screen. The only difference is that it's written a little differently. Okay, so we have this function, how many? It takes in I and j. That's the position that wherever we click of the element that we choose. The element is the part in the HTML that's clicked. So whatever one we choose, we're getting that index of I and j as well. I have a sum that I started at 0. This is so that I can add the values as I loop through the square. I'm essentially creating an inner loop of this square, a 3x3 loop of whatever sender value we've chosen. So whatever value that we choose, no matter where we pick any arbitrary value, it's going to be minus 1i, right? Because if this position is I is 1, 0, 1, 2, 3, 4. Okay, so this is index 4. We're going to want to start at index 3. This is for, as far as rows are concerned, that is index 3. So I is at 3, or you can say it is at I minus 1. So we start at row I minus 1, and column position, we said our columns are going to be defined by j. So j minus 1. So our column j minus 1. And when we start at that value, then we start at 9. I minus 1, j minus 1, we're starting at 9. Okay, I get a little bit too, okay. So I said here, we're looping through this. So we're starting at I minus 1 until we get to I plus 2. Because at I plus 2, we have gone out of that square. I plus 1 is this row below here. I plus 2 is this row below. So we've gone out of that square. So that's what I have written here. Excuse me, I'm trying to scroll. Okay, so I said K, this is our index for our inner square. K equals I minus 1. And while K is less than I plus 2, increase K. That's going to make us go through the rows that we need of that 3 by 3 square. We're not starting at 0. It's just any given position that we click, that value of I and J, whatever value at I that it is, we're going to say start it at this value K, which is going to be equal to I minus 1. And while K is less than I plus 2, while we're still in range of that square, then increase K. This will iterate through 3 rows. I minus 1, this will iterate through 3 rows surrounding and including I's row. And then here, we're doing the same thing, except for with L for the columns. When we start our square, we're starting 1 column to the left, so that's J minus 1. 1 column to the left of the original position we started. And while it is still within the square, okay, while the column area, while we say, well, L is less than J plus 2, because J plus 2 would have been 2 columns to the right. That's outside of the square. So while L is less than J plus 2, while we're still within bounds, increase through the columns. So this would iterate through the 3 columns surrounding J's column position. Okay. Now these 2 for loops together would iterate through that 3 by 3 square. Okay, then we have an if statement. Let's just comment out this if statement for now. Ignore the 47 and 49. So for that 3 by 3 square, we're going to add to the sum that position, the dojo at K and L. This if statement then is going to check for edge cases. Because what if I click the corner or the edge? That 3 by 3 square is going to wrap some, it's going to, let me just go ahead and draw it out. If I choose this corner piece at 0, it's still iterating by 3 by 3 square, but all these values on the top and on the right would be undefined. So we don't want to add undefined to the sum, because then you cannot add undefined as a number to the sum. Undefined, it doesn't have a value. So we say if the dojo at K, if it's not equal to undefined, if it doesn't have an undefined value, and if the dojo at the column space is not equal to undefined, essentially this is asking if the iteration points have values to add to the sum. If the iteration points have values to add to the sum. In other words, not undefined values because we can't add undefined values to the sum. This checks that nothing is undefined. If nothing is undefined, then we add to the sum. Okay, once we have that final sum, we say element.innerText equals sum minus the dojo at I and j. The dojo at I and j is that centerpiece. So all I'm doing is adding that sum of that 3x3 square that it would iterate through and subtract that center value, the dojo at I and j. Okay. Does anyone have any questions about this? Okay. When I was a student at the dojo, it was at this point in the morning algorithm lectures that I would just sit and I would just try to absorb as much as possible, but there would be it would start to go over my head so much that I didn't even know what to ask as a student. I didn't know what I was just barely grasping on to whatever was taught and trying to hold on to it for dear life before the next day where I was given a whole new challenge that was like another challenge over my head that I didn't know what to ask in order to be, an efficient learner. So if you feel that way, that's normal. Don't give up. If it's becoming like so heady that you're barely grasping on, that's the way it's now designed. So every algorithm challenge that I'll be giving you guys next week, I'll be trying to push you to the very limit of trying to grasp the answer, conceptualize the answer, and then the next day I'm going to give you a whole new different challenge that's going to maybe wash away with the progress you made the previous day. Okay, so now we're going to be hitting you hard with these algorithm challenges, and this is the first one that is a real challenge. Not everyone completes this the first day, but since we're not working really hard on anything else other than listening to the lectures today, what you guys can do is take this solution that I'll post on GitHub and dissect it, understand it. Once you understand it better, you'll have a better grasp of how this works. And if anything similar comes up in the future, you would have known, oh, I knew how to do that at one point. I can look it up and I can search that answer. Okay. So it's not trying to memorize now how to do everything. It's just trying to understand and remember that we at one point knew how to solve it. So you could go back to research that previous answer. Okay, so there's no way you're going to remember how to do every type of algorithm. There's probably hundreds of algorithms out there. You're just trying to improve your overall problem-solving skill at this point, which can be applied to any algorithm. Your problem-solving skill is now what I'm trying to target and what the rest of the instructors would be working on as they give you brand new challenges, and the next day it's going to be a whole new challenge. We're trying to get you familiar with the types of challenges you would run into. So if you ever run into it on the future when you're on your own, it's not going to be completely unfamiliar to you. Or if you're teaching yourself some new challenges, it's not going to be so painful to learn by yourself, because you would have known at one point, at one morning for a couple hours, I did solve this, so I know I can solve this if I encounter it again. Okay, so this is how you would iterate through a 3x3 square within a 2D array, gather the sum of that 3x3 square, and add it to the element inner text of whatever was clicked. Okay. So if you work on this further and do all the bonus challenges today, then you would have created the Minesweeper game. That Minesweeper game you would have played maybe in the mid-90s or early 2000s. Okay, so is there any questions then? Nope. Okay, let's take a break and get our minds ready for Kaya's lecture.